Thank you. So I'm here. So while the presentation starts, I want to thank President von Braun for inviting me. I have a quite difficult task, actually, in the spirit of this conference, thank you, to share knowledge, first of all, which, of course, so my goal is to try to convey what the astronomers have learned, have understood of the universe, and what have not understood of the universe. Can the presentation start, please? And at the same time, to share the knowledge of the path to knowledge, how we learn things, how we understand how the universe is made, what the universe is made of. No. No. I can try to make your presentation, so I'm not sure. I'm not sure you would be. Okay, here is coming. Okay, so now I like to start from this nice picture, which is just a picture, not taken from a telescope, but it's the starting point. So the starting point in mankind looking at the stars is that the universe and the sky is so beautiful, and we have heard so many examples of how all the cultures on our planet look and use the sky. And I also want to mention that astronomy, for this reason, is one of the oldest science in mankind. I was impressed when I visited Mexico several years ago to see this ancient observatory in Chichen Itza, which looks exactly like a modern telescope, like this one in Mauna Kea that Doug has just spoken about. And as you see, astronomers are all alike. So whenever they go, they put on top of a hill and they build a door. So, and this is what we have been doing for all the history of mankind. So, seriously, to show how we act, let me use the words of some of the most famous astronomers, and the first is Galileo, who has been mentioned today as one of the founders of this academy. And you know that he has been the first to look to use a telescope to look at the several things, including the Milky Way. And as you know, the Milky Way looks like a haze, and all cultures in mankind have different stories about what the Milky Way is, different names. And he was the first to look at using the telescope, look at the Milky Way, and discover that the Milky Way is actually made of stars. And his words are very clear. By the aid of the telescope, anyone may behold, and we see these things, appeal to the senses. So we see these things with our eyes. And what we found is that the galaxy, the Milky Way, is nothing else but a mass of innumerable stars. And wherever you look at, you could see a vast crowd of stars presents itself to view, and the number of small ones is quite beyond determination. So I really sense the sense of wonder that Galileo, imagine the first time Galileo looked in his telescope and saw these things. The sense of wonder is what drove him and is driving us today. Now, 3 centuries later, another important astronomer, Edwin Hubble, made another discovery, not only that the Milky Way is made of stars, but there are other galaxies like the Milky Way. And again, he was the first to use the biggest telescope of the time, and again, the first looking inside the data, inside this telescope. He was able to acknowledge that this object is another galaxy like the Milky Way. And let's look at what he wrote, and you may see that he used exactly the same scheme that Galileo used 3 centuries before. So first of all, telescopes have continued to develop until today. So again, we are using telescopes, and what we see is that the outer regions are inhabited by stellar systems comparable to our system of the Milky Way. And we find them scattered through space as far as telescope can reach. This is exactly the same sentence that Galileo used 3 centuries ago, the same sense of wonder that Galileo felt at that time. And this is what we do. We use telescope bigger and bigger, better and better, to explore the universe. And the reason for we do it, why we do it, again in his own words, is that these telescopes allow us to survey and study a sample, just a little part of the universe. But from this small sample, we are able to infer the nature of the universe as a whole, so to understand how nature and the universe is made. That's why we explore space. So briefly, what have we understood? Well, let me mention a couple of things. One is that planets are common in the universe. We have discovered more than 5,000 planets around other stars, not talking about our planetary system, but around other stars in the Milky Way, to the point that we believe today that every star in the Milky Way, or nearly every star, has at least one planet, probably more. Not only we detect planets, but we can even study their atmosphere. We can see if they have clouds, if there is rain, what is the temperature of these planets. And we have discovered that there is an incredible variety of planets, dimensions, masses, temperatures, chemical composition. No, we haven't found two planets alike, let me put this. What we have not understood or discovered yet, first of all, we have not discovered yet any planet really really like the Earth, so with the same size, mass, and proximity to the sun. We don't know really well how planets form around stars, so we don't know how common Earth-like planets are. And we have no idea of whether life exists elsewhere, on how frequent it is. So we are actively searching for signatures of life, but we haven't detected any so far. And my takeaway message is that conditions in the universe are typically hostile to life. So it's really not easy to find nice places to stay and live outside the Earth. Then if we look outside our Milky Way, Hubble discovered the very first galaxies. Now we know that the universe is literally filled with hundreds of billions of galaxies. So their number is incredible. They come in a variety of sizes and shapes, from a very small, what we call dwarf galaxy, which are, say, only 1 million of stars each, to giant galaxies with a million of stars. So it's a range in size and number which is really astonishing. But even more astonishing is that we can observe backward in time. So if we take an image with our telescope, you see all the points, all the objects you see in this image, most of them are actually galaxies incredibly far away, and the smallest one are even more distant, and we see them smaller because they are more distant. And since light took a lot of time to reach us, we can see these galaxies as they were billions of years ago. So we literally go backward in time. So distant galaxies are observed when the universe was younger, and we see that these galaxies change over time. So we see with our eyes that early galaxies, when the universe was nearly born, are clearly different from present-day galaxies. It's like paleontologists can look at the bones and reconstruct how animals were in the past. That's exactly the same thing. In our telescope, we see how the universe was billions of years ago. And what have we learned from these observations? We have learned that the universe has an history. It started about 13.7 billions of years ago. This is clearly demonstrated. We see that the universe keeps expanding and is expanding faster and faster. And so if you go back in time, we go to the point where everything started from an infinitely dense phase that we call Big Bang. You know, this was a joke, but eventually was used in popular term because it clearly gives the idea. So this is what we have understood. What we have not understood or discovered yet is what drives this expansion of the universe. We have found a fancy name, dark energy, but we have actually no idea what this dark energy is. So what is the fundamental law of nature that is driving this accelerated expansion of the universe? Of course, we cannot address the question of what really this Big Bang was. If there was a before the Big Bang, maybe not. Maybe time created that time, or maybe there are theories that predict something different. And there are even theories that predict or postulate that may exist other universes, not only our stars, not only other stars or galaxies, but even our other universes. So as you may see, most the range of things we have not understood is much larger of the things than the things we have really understood. So before drawing my conclusion, let me say another thing, again in the spirit of this meeting, that observation of the sky is at risk. As you know, there are thousands of low orbit satellites which are being launched nearly every week. And you may see there is a major concern among astronomers on the impact that this constellation will lead. And now, as today we have a few thousands, but there are hundreds of thousands of satellites which are planned in the very next years, and they are highly visible. So they will not affect, they will affect, of course, astronomy, and as you see on the left, the trail of these satellites on the stars. But this is a problem for whole human observation, because it's something which completely changes the vision that we have, even with the naked eye, of the sky. And so all the traditional knowledge that has grown over centuries of what the sky is will be significantly affected by these constellations. So this is a serious issue. Astronomers are, it's written there, they are frustrated. We are not frustrated, we are worried, and at the same time we are actively discussing with the company and with the United Nations to see if there is a solution or a mitigation to this problem to be pursued. So my conclusion, so far we have explored, the truth is that we have explored a very tiny fraction of the universe, and I can say that it's astonishingly wide, beautiful, and diverse. So the diversity of the universe and the conditions in the universe is what strikes me the most. We have not yet answered fundamental questions about the origin of the universe and of life, and we're working hard on this. And my takeaway is also that conditions for life may be difficult to meet in general. So my overall conclusion is that we really have to take care of of our unique home, the Earth, because it's not going to be fine finding anywhere else to go. Thank you.